Hi everyone. It is time for us to start looking at the 7-4 worksheet, which does tend to be a pretty tricky one for some people. So I'm going to try and explain this to the best of my abilities here. But there are many different ways to do these problems, so sometimes it can be a little bit tricky to kind of decide how you are going to approach the problem. So let's look at number 11. 11 says, consider triangle XYZ with the altitude to the hypotenuse ZW. Describe a sequence of transformations that maps triangle XYZ, the big triangle, onto triangle XZW, which is the little triangle here. So how do we go from the main big triangle to that small triangle? So of course, first we need to make our big triangle smaller. So we're going to dilate triangle XYZ. Dilate triangle XYZ by a factor of basically the new side length divided by the old side length. So by a factor of, we'll use the new long side, XZ, divided by the old long side, XY. And let's see, maybe we'll make the center of the dilation point Z so that it's still around that same spot. With center of dilation Z. Then we need to, now that we have the small triangle and it's going to be little and right here, we're going to need to reflect it and rotate it so that it lines up with triangle XY or XWZ. So we can say reflect and rotate. So XZ, we'll just pick one of the sides. So the long side XZ lines up with the other long side with, in this case, X prime, Y prime. B, describe the sequence of transformations that maps triangle XYZ, the large triangle, onto triangle ZYW, the medium-sized triangle. So again, this whole problem is just showing us how the three triangles in this picture are similar. So to make it the medium-sized triangle, of course, we would have to dilate because we need to make XYZ smaller. So dilate triangle XYZ by a factor of, we'll go new long side over old long side. So YZ over XY with center Y. That'll make it easier because that means we're just squishing this triangle down this way. Because after that, we'll just need to rotate. We can say then rotate. So, and then we'll take the long sides again. So XY lines up with ZY. So the long side of the large triangle, we'll actually call that X prime, Y prime, lines up with the long side of the medium triangle, ZY. Number 12, Amaya was asked to find DC. What is Amaya's error? So she chose to use AC over BC. So let's see, she's showing that ABC is similar to ACD. ABC is the large triangle. ACD is the small triangle. So she said AC over BC. That is the smallest side over, so the smallest side of the large triangle over the medium side of the small triangle. Nope, sorry. AC over BC. AC is the longest side of the small triangle over the medium side of the large triangle. Those are incorrectly corresponding sides. And AC over DC is the shortest side of the big triangle over the long or the medium side of the small triangle. These are incorrect choices for proportion of the sides. So we can say she used incorrect correspondence of side lengths. All right, we're going to talk about geometric mean here. So the geometric mean of two numbers is when we multiply them together and take their square root. And it happens when we have two pieces and an altitude to the hypotenuse that's broken up by those two pieces. Of course, CD in this picture is not the altitude to the hypotenuse, it's the median. So AD and BD, they're the same. CD is not the geometric mean of them because they're the same amount. So if it was an altitude, it would work, but since it's a median, it doesn't work. So we can say no because, and we can explain this a few different ways. We can say CD is not the altitude, it is the median. Is the median. All right. This next one, this one's a little bit crazy. This is the higher order thinking question. Suppose the altitude to the hypotenuse of a right triangle also bisects the hypotenuse. What type of right triangle is it? Use the similarity of right triangles theorem to explain your answer. So let's draw a right triangle. Like that. Weirdly, it lines right up to draw the altitude on this line. So you can say here's the right angle in the right triangle. The altitude here says the altitude also bisects the hypotenuse. So now that is bisected. And the altitude hits the hypotenuse at a right angle. What type of triangle is it? Use right triangles to explain your answer. So what you might come across very quickly is that this must be an isosceles triangle. So we can say it must be an isosceles right triangle. And then we have to say why. So because we know that the altitude is the geometric mean of both parts of the hypotenuse, then what we can say is it'll be the same as each part of this hypotenuse since it bisects it. Because if I multiply this times this and I divide, or not divide, but take the square root, essentially I'm taking an x and an x. If I do x times x, I get x squared. And if I take the square root of x squared, I just get x. So this piece right there is going to be x as well. So we can say, so the altitude, since the altitude is the geometric mean of both parts of the hypotenuse. Of both parts of the hypotenuse. So the altitude, will be the same as each part. Be the same as each part. So that means that the small triangles must be isosceles triangles if they have side lengths x and have a right angle, side lengths of x and have a right angle. So then we can say the small triangles are isosceles right. The small triangles are isosceles right. So the large one is 2. Large one is 2. So we've just shown that main triangle, the original triangle, is an isosceles right triangle. Number 17, what are the values of h and x in the right triangle? Here we can use some ratios to figure this out. So I can look at the pieces of triangles that I have and use them to come up with the pieces I don't have. If I look at this medium-sized triangle right here, I have the medium length side and the long length side of that triangle. If I look at the small triangle right here, I am looking for the medium length side and I have the long side. So putting those together in proportion will give me one unknown piece. Because I can say median length side h over long side 65 is equal to median length side 144 over long side 156. Then I just need to cross multiply. I get 156h equals 144 times 65. Let me grab my calculator real quick. 144 times 65 gives me 9,360. And then if I divide both sides by 156, I end up with h equals 60. So there's 60. Now that I know that h is 60, I can use that value to find x. I can say 144, this median length side of the medium triangle, over 60, the short side of the medium triangle, is equal to 60, the median length side of the medium triangle, over x, the short side of the small triangle. Both of them are the small triangle, sorry. So if I do 144 over 60, medium side over short side, equals 60 over x, medium side over short side. So I cross multiply, 144x equals 3,600, right? 60 times 60, let me check. Yep. And then I'm going to divide both sides by 144. And I find that x equals 25. There we go. Those are our two values. All right, next 18. What is the value of y in this right triangle? Here we have a position where we can either use our proportions or just our regular old altitude on hypotenuse theorems. So if we use proportions, I could say that 12, the medium side of the medium triangle, over y, the short side of the medium triangle, is equal to y, the medium side of the small triangle, over 6, the short side of the small triangle. Or I could skip right to the next step and say that the two pieces of the hypotenuse multiplied together are equal to the altitude, and say 12 times 6 equals y squared, because the altitude squared. So 72 equals y squared, and then the square root of 72 is equal to y. The square root of 72 is approximately 8.48. And again, we'll actually go over how to simplify square roots next chapter. So 8.48 is the value of y. We can use these same theorems as we continue on. What are the values of a and b in each of these right triangles? I can make some proportions, or I can use altitude on hypotenuse theorems. So I could say that the long side of the big triangle over the medium side of the big triangle is equal to the medium, or the long side of the medium triangle over the medium side of the medium triangle. So that would be 25 over 20, over 20 equals, and then long over medium, so 20 over a. See how that makes 20 the geometric mean of 25 and a? Or I could use an altitude on hypotenuse theorem that reminds me that the leg squared is equal to the piece of the hypotenuse closest to that leg times the whole hypotenuse. That's just what happens when I cross multiply here. the leg squared, 20 squared, is equal to the piece of the hypotenuse times the whole hypotenuse, 25a. So that gives me 400 equals 25a. Divide both sides by 400. And nope, I'm not dividing both sides by 400. That would be wrong. I'm dividing both sides by 25. And I end up with 16. All right, and the other one, same thing. I can choose to make a proportion that tells me that long over short, so 625 over 175, is equal to long side of the small triangle, 175, over short side of the small triangle, B. Or I can use my altitude on hypotenuse theorem that tells me that the leg squared is equal to the piece of the hypotenuse times the entire hypotenuse. So that would tell me the same thing as cross multiplying. 175 squared is equal to the piece of the hypotenuse times the whole hypotenuse. That would be 625b. And then I'm going to solve this. So I have 30,625 equals 625b. And then I'm going to divide both sides by 625. And I end up with 49 equals b. And that's my answer. All right, let's keep going. These take a long time to explain. Ooh, we've got some quadratics. So here, if I want to find the values of m and n, again, I'm looking for proportions. I see that I have the medium side and short side of my medium triangle and the medium side and short side of my small triangle. So I can say 2m over 8, medium side over short side, equals 8 over m minus 4, medium side over short side. And then I can cross multiply those. So that's going to give me 2m times n minus 4, just like that, equals 64. 8 times 8 is 64. So then I'm going to distribute 2m times n minus 4. I get 2m squared minus 8m equals 64. And now I have a quadratic. So I'm going to need to solve this quadratic. So let's move everything to one side by subtracting 64. That gives me 2m squared minus 8m minus 64 equals 0. And then let's divide everything in this equation by 2, because everything is divisible by 2. And when I do that, I'm going to get a much simpler equation. M squared minus 4m minus 32 equals 0. And I'm going to see if I can solve that by factoring. So I want to think of two numbers that add to negative 4 and multiply to negative 32. And I think, oh wait, negative 8 and positive 4 multiply to negative 32 and add to negative 4. So I'm going to write m minus 8 and m plus 4 equals 0, so I factored. And then I use the zero product property to say that means that m must be equal to 8 or m must be equal to negative 4. And since I have a side length here that is 2m units long, and I know that it needs to be a positive number, then I know negative 4 is not a possible answer of this question. So 8 is the only true solution for this system. So I have 8 as my m. In B, we're going to do a very similar process here. We know the proportion that we can make. It's going to be long side over, the medium side of the big triangle over the long side of the big triangle. And then we can do the medium side of the medium triangle over the long side of the medium triangle. So I can make this n plus 3 over 16 equals 9 over n plus 3. Then I can cross multiply. N plus 3 times n plus 3 equals 16 times 9. So n plus 3 times n plus 3 is n squared. I'm foiling here. N squared plus 3n plus 3n, that's going to be plus 6n plus 9 equals 144, which is 16 times 9. And in order to solve this quadratic, I need it to be equal to 0. So I'm going to subtract 144 from each side. And I'm going to get n squared plus 6n minus 135 equals 0. And I'm going to factor that. I'm going to think of two numbers that multiply to negative 135 and add to negative 6. Add to positive 6. I might need to do some playing around on my calculator to find that those two numbers are 15 and negative 9. So I have n plus 15 and n minus 9 equals 0. And then I'm going to find, using the zero product property, the opposites. So either n equals negative 15 or n equals positive 9. And since n plus 3 needs to be a positive side length, that rules out negative 15. So the only possible answer is that n equals 9. Number 21, what is the value of w in the right triangle? So we've got lots of ways we can find this, but what I see here is I see an altitude on hypotenuse diagram like I'm used to that has another altitude drawn to another hypotenuse. So instead of 3 similar triangles in this arrangement, I actually see 4 similar triangles in this arrangement, or 5, depending on how you're counting. I see a lot of similar triangles here, is what I'm trying to say. So I need to find the similar triangle proportions that are going to help me solve this problem. So one thing that I see is that 5, the length of the long side of the small triangle here, over 4, the medium side, I could do long side over medium side of this triangle right here, 10 over w. And since they're similar triangles, they have to be, that's what I'm going to do, is 5 over 4 equals 10 over w. I'm going to cross multiply, so that's 40 equals 5w. Divide both sides by 5. And I find out that 8 equals w. And then it says explain. We can explain by saying that all the triangles are similar to each other because we've drawn another altitude. All the triangles are similar to each other. So we are allowed to make the proportions that we can make to solve the problem. Number 25, for each figure, write an equation that you could use to find the value of x. We could be using our altitude on hypotenuse theorems here. So we can use proportions or we can use altitude on hypotenuse theorems, which is what I'm going to show. So I'm going to say for A that I know the two pieces of the hypotenuse multiplied together are going to be equal to the altitude squared. For B, I'm going to use my other altitude on hypotenuse theorem that tells me that the leg squared is equal to the piece of the hypotenuse closest to it times the entire hypotenuse. So x times 21. Again, you could make proportions here. You could make a couple other things. Number 22, Jake wants the profile of a hotel he is planning to be a right triangle with the dimensions shown. So he's seen some right angles here. And here we've got an altitude drawn to this hypotenuse. The city prohibits structures over 100 feet at the location where he would like to build. Can the hotel be located there? We want to figure out whether the altitude x is taller or shorter than 100. So we've got to figure out how we can do that. So I think that the first thing we need to do is find the lengths of the pieces of the hypotenuse, because those are the only pieces of information we can use to find the length of the altitude. So if I'm trying to find this piece of the hypotenuse, that is that's connected to a leg of the triangle. So at this point, I'm just using altitude on hypotenuse theorems. And I can say the leg squared, 160 squared, is equal to the piece of the hypotenuse closest to that, which is, I'll call it y, times the entire hypotenuse, 200. So 160 squared is 25,600 equals 200y divide both sides by 200, and I get 128 equals A, or, well, I guess it's not A, it's Y equals Y. So I can say this piece of my hypotenuse is 128 units long, which means that the other piece of the hypotenuse is 200 minus 128 units long, which is 72 units. And now I know that the altitude in an altitude on the hypotenuse problem is the geometric mean of the two pieces of the hypotenuse. So I can say 128 times 72 is equal to altitude squared. And I can solve that. That gives me 9,216 equals x squared. If I take the square root of both sides, that is going to give me 96 equals x squared. And the question was, can the hotel be located here? Since this hotel is less than 100 feet tall, we can say yes, the hotel can be located here. There we go. Next, which triangle is similar to ABC? So in this case, we're just looking at the order of the letters. So if I trace triangle ABC, I have small angle, right angle, medium angle. We need to figure out which one of these arrangements of letters goes small angle, right angle, medium angle. So CBA goes, it's the same triangle, so that's not going to work. ABD is this medium-sized triangle. That goes small angle, medium angle, right angle. That's not the right pattern. For CDB, that's the little triangle. That goes medium angle, right angle, small angle. That doesn't work. For BDC, that goes small angle, right angle, medium angle. So D follows the same pattern and is similar to triangle ABC. I know that's kind of a lot. I hope this video did help. It's a lot of work to do these altitude on hypotenuse problems and remember what you're supposed to do. So make sure if you've got any questions, you ask me in class. All right, thanks so much and have a great day.